going to call this kind of a 3-7 introduction to implicit differentiation, which is what section 3-7 is. So I made it video number 1 because I thought the notes needed a little more intro. So up until now, because you've never seen implicit before, we've been doing, oh, by the way, these are the notes that I gave out in class on Friday. So if you weren't there on Friday, you could wait to watch this video until you get this handout on Monday. So right up until now, we've been doing explicit equations where we had y on one side and x on the other. Y on one side, x terms on the other. So that's what our equations have looked like. And then we took derivatives. We would find dy dx. So we would take the derivative of y with respect to x, and we'd only have x's over here. And on this one, we would find dy dx, the derivative of y with respect to x, and we only had x's on that side. Well, when you have equations that have both x's and y's all mixed up on the same side, that's when implicit comes in handy. Now, if it's a simple equation, you could solve for y and still find dy dx, but you'll see we'll have some complicated ones where you don't want to solve for y first, you just want to go ahead and take the derivative. That's what implicit differentiation is. You have two different variables. So it's normally x's and y's, but it could be x's and z's, x's and p's, could be any other variable. So let's look at an example here. If we have this, we're asked to find the derivative of x squared. You can think we have an x here, a dx, and we have an x here. Or you can think about it as everything matches. X is x's, and the derivative is 2x. What if we had something like this, where we have a y and a d dx? So we're asked to take the derivative with respect to x, but we have a y term. So everything doesn't match. But you can think, if I think of dy dx and d dy, so I'm really wanting to take the derivative with respect to y. And if I multiply that by dy dx, you can picture these dy's canceling. So that's the same thing as finding what they asked for, right? They asked for derivative with respect to x of y squared. Well, if I do derivative with respect to y and multiply it by dy dx, that's the same as finding the derivative with respect to x. And what it ends up looking like is, I'm going to put the dy here in the middle, so the y's are by the y's, and I'm just going to have this dy dx hanging off the end. So now I'm going to take the derivative just like we always do. If I'm taking the derivative of this with respect to y, I would just get 2y and then times dy dx. So notice I took the derivative like normal, but I added this dy dx. And that's how you do implicit. Whenever you're taking the derivative of something other than x, you're going to stick on a dy dx. This is really what you're doing. You're not going to think about this long process. You're just going to add a dy dx. So the procedure is take the derivative like normal, and you're going to add a dy dx where needed. And where do you add it? When you're taking the derivative of anything that's not an x, right? So if you had y's, then you would add a dy dx if the other derivative was a y, or the other variable was a y. If the other variable was a z, you'd add a dz dx. If the other variable was a g, you'd add a dg dx. Okay, so you're adding that dy dx whenever you're differentiating anything that isn't an x. And then you do some simplifying. You are combining or accumulating the dy dx's on one side of the equal sign, and then you solve for dy dx. So let me show you what it looks like in a problem. So this is the problem I gave you. It's on the back of your notes. Actually, I'll just do it right on here. No, I'm going to do down here. Okay. So this is a little bit of a messy one. The ones in your notes start out a little more basic, but this is okay so you can see an ugly one from the get-go. So remember the directions for this would be to find dy dx. So the process is I'm going to take the derivative like normal, except whenever I'm differentiating a y, I'm going to add a dy dx. So x squared, derivative of that would just be 2x. Now here you have to be careful. This is actually the product rule because I'm taking the derivative of x and the derivative of y. So I'm going to put plus and I'm going to put this in parentheses. So this is where I'm doing my product rule. So the first would just be x times the derivative of the second. The derivative of y would be 1 dy dx, or just dy dx. I'm not going to write the 1. Plus the second, which is y, times the derivative of the first. Derivative of x is just 1. Okay, so that's the product rule here. Now cosine y, the derivative of that would be negative sine of y dy dx. I just differentiated a y, so I need to add the dy dx. And this is going to equal derivative of 8y is going to be 8 and add the dy dx. Okay, so wherever I took the derivative of a y, here, here, and here, I added the dy dx. Now the next step is you're solving for dy dx. So you want dy dx all alone on one side of the equal sign and everything else on the other. I'm going to switch pencils here, see if this shows up better. So the first thing I want to do is to get all the dy dx's on the same side of the equal sign. So I have a dy dx term here and one here. So I'm going to minus the 2x and minus the y from both sides of the equation. So I'll just write it like this. I'm going to do it in one step though. So minus 2x and minus y. So over here I'm going to have x dy dx minus sine of y dy dx equals 8 dy dx minus 2x minus y. Okay, now I want this dy dx term over here with the others. So I'm going to minus this from both sides. So I'm going to have x dy dx minus sine of y dy dx minus 8 dy dx equals negative 2x minus y. Okay, now I got all the dy dx's on one side, so I'm going to factor out my dy dx. Each term has a dy dx in it, so I'm going to factor that out. I don't know why this is showing up weird. Maybe that will help. Okay, so if I factor out a dy dx here, I have x minus sine of y minus 8 equals negative 2x minus y. Now, if I want to get dy dx alone, I need to divide both sides by all of this. So dy dx is going to equal negative 2x minus y divided by x minus sine of y minus 8. Okay, so this is dy dx. Remember, we started out finding dy dx. Boy, this is hard to read. I'll move that down and see if you can zoom that in a little and read it better. Okay, so in summary, whenever you're taking the derivative of a variable other than x, you need to add dy dx, or multiply by dy dx. Okay, now I would go on and watch the videos that follow along with your notes.